Okay. Right. Okay. Good evening, all. We'll start now. It's 7:05. Yeah, 7:05. We'll start. It seems there are more students to be joined, but since it's 7:05 now, we'll start anyway. Yes. Okay. How about the audio and the video? Is it clear? Okay, it's fine, right? It's fine, right? Okay, right, it's okay. Right, listen. Okay, listen. Right. So today, we are going to start this special program, specially designed to recap mechanics. Right? Recapping in the sense, we'll be going a full round again around mechanics. Right? Around mechanics, a full round starting from scratch, starting from zero. You are going to go a full round around mechanics until fluid dynamics, until the very end of mechanics. Right? The reason to start this kind of a special program is because I got few inquiries from some of the students, especially from batch 26. Because now the thing is, so now you know, since most of you are from batch 26, you know the criticality of mechanics, the important significance of mechanics. And we know mechanics is the first unit, right? First unit in the sense there is actually second in our lineup, but there is a first unit that is going to be connected to, link to all other coming up units, right? So therefore, without having a solid base for mechanics, right? What happens is when we are moving forward, again in other coming up units, we are going to get stuck because of the lack of knowledge of mechanics. The reason is all the basics, fundamentals about motion, mechanics, vectors, right? And projectiles, linear motions, energy, work, friction, circular motions, rotational motions, hydrostatics, right? All the fundamentals are in mechanics, right? All the fundamentals are in mechanics. So therefore, now when we are moving forward, if your mechanics base is not that satisfactory, at some point you have to pay that price. Definitely at some point you have to pay the price, right? So that is the thing. Now as an example, let's say we are studying gravitational fields. In gravitational fields, it is mostly driven using F equals ma and circular motion, right? F equals ma, circular motion, and actually energy, right? Conservation of energy. Now, if your mechanics knowledge on such areas is not that good, not that satisfactory, and in such kind of scenarios, you have to pay some price. You have to get stuck at questions. That is one, just one example, right? For electric fields, magnetic fields, everywhere, anywhere and everywhere, mechanics is connected, right? So therefore, having a solid knowledge, a thorough knowledge about mechanics, and having a thorough comfortability about mechanics is kind of vital when it comes to our A-level journey, right? So therefore, with the few inquiries came, finally I decided to start this program on bounce back mechanics, right? That was the reason. That was the exact reason, right? Why is Zoom it working? I'm watching. Okay, that's fine. Yeah, YouTube one is working fine, right? Yeah, it's working fine. Yeah, it's working fine. Okay. So listen. So that is why we decided to start this program of bounce back mechanics, right? First, I'll quickly brief the lesson plan, the plan of this program, and how we are going to conduct the program, right? And first thing, this will be conducted as a fully online program, right? Fully online program, and it is planned for 16 days. 16 days in the sense 4 months. This is planned for 16 days, 4 months, right? Something like this. Say, something like this. First thing is a full-time online, full online program. This is a full online program, right? And this is planned for 4 months. Planned for 4 months. This is planned for 4 months, right? It won't take more than 4 months anyway, right? Worst case scenario, it goes up to 4 months, right? So that is why I say it's planned up to 4 months. Sometimes it might be finished, right? Based on the speed that you are doing questions, you are doing the things here. Sometimes the number of days can be slightly differ. Right? For now, permanent time for this program is going to be this. Permanent time is going to be this. This will be on every Wednesday from 7 p.m. to say it's 10:30, 7 p.m. to 10:30, or it is actually extendable up to 11, right? 10:30, 11. It is extendable up to 11. Right? Initially, I planned it for up to 10, but for sure, I know when we have started the program, when we are working on the program, so definitely we will have to spend around 3:30 to 4 hours, 3.5 hours to 4 hours, right? So therefore, as a rough time, just know that this will be starting at 7, and this will go up to like 10:30, 11, something like that, right? And this is a permanent time. At 7. This is the permanent time, right? Is it blurred on YouTube? Is there any problem? Oh, working fine. Let me check. It's fine, right? Give me 1 second. For me, it's fine. Let me check. Okay. Okay. Listen. And the permanent time is going to be this, right? Wednesday at 7. And the program is planned like this. We'll be starting everything from 0, right? Everything from 0. And all the theories with the applications, with the questions, with the applications will be covered during the period, right? So mainly parts we have in mechanics are linear motion, projectile motion, vectors, Newton's laws, linear momentum and energy, then force equilibrium, center of gravity, friction, rotational motion, circular motion, hydrostatics, hydrodynamics. Those are the subparts, sub-lessons, subparts we have in mechanics, right? And in weekly basis, we'll be covering each part in this program, right? So initially, I'll be explaining all the relevant theory parts, and then the plan is to quickly move on to the questions and make sure you are comfortable with the questions, with the things you are learning on a particular day, right? That is the whole purpose here. Right? So therefore, now this will be a little bit faster than the speed that we are doing in a regular theory class, right? So therefore, now since this is a kind of a fast track recap program, right? I'll be covering the things a little bit faster. So therefore, from your side, what you should do is always you should do questions, you should take down the note and everything kind of faster manner, right? Now you are here because of you didn't learn mechanics properly at the first place, no, right? That is the thing. So therefore, now this is your second chance. Since this is your second chance, now you have to put some more effort, and you have to stay with the program. You have to be with the program, and both of us should contribute for the program. Right now, from my side, my delivery will be kind of faster, and I'm trying to deliver everything that I'm planning for the day, because we have a daily plan. For this program. So therefore, always my target is to deliver everything that we need to cover during a particular day, right? So whether it takes 3.5 hours or 4 hours or more than 4 hours, right? That is how I have planned, because this program goes as a 16-day program. So we have to have a daily plan. That is how this program goes, right? So therefore, from your side also, you have to put your fullest effort and be here, right? Now, even though it will be kind of faster, it doesn't mean that you are going to miss any theories. Everything will be covered, but kind of a little bit faster manner, because now usually when you are learning mechanics, you are newbies to A levels, you are new to grade 12. But now, since we are learning mechanics here in BOUNCEBACK program, now you have been in this A level journey for around 1.5 years of time. You have already been with the A level journey, so you know how this goes, and you are more comfortable with like simplifications, copying down the notes, words, the jargons and everything. So therefore, we have to go with that phase. We have to tackle that speed. We have to go with the phase, right? Okay, and other than this day, listen, other than Wednesday, again, I'll be merging you, I'll be joining you with another class that is actually ongoing. That is actually my ongoing batch of 27 for some of the lessons, right? For some of the lessons. Then there you will learn all complete theories, because that is my theory class. You will learn all complete theories for some lessons from that class, right? So therefore, now during these 4 months means 16 weeks. No, during these 16 weeks, you have to put some more effort, and you have to join both classes, because now if I asked you to join a regular batch class for a particular lesson, right, that is because of the fastness, because of the requirement of covering your thing faster, right? That is a better approach. No? You can manage 2 days. And even though it is joined, your fee will be same, right? There's nothing like that. So what you should do is, once you register for this bounce back program, I'll make it free for the regular 27 batch. Now, actually, in regular 27 batch, center of gravity is to be started, right? So therefore, now my plan is to connect you with 27 regular batch from center of gravity, because there are no major links for center of gravity. There are no major links for center of gravity with the initial parts we are covering in mechanics. So therefore, likewise, there are some parts, some small parts in mechanics that we can cover isolatedly. Without having like major connections, major links. Right? For such cases, for such ones, I'll be linking you with the regular batch, and regular batch is on this day. Regular batch is on Friday. That is on Friday at 3:30. That is at Friday at 3:30. That is Friday at 3:30. Right? So therefore, now even though I say it's 16-day program, right? 16 means 16 Wednesdays like this, and in addition, you will be joining for the Friday class for some of the lessons, right? And in this class, my plan is to cover up to those parts, up to that point, without repeating the lessons that you are covering from this batch, right? So purpose of doing it is to you to deliver more things, from mechanics in weekly basis, right? So therefore, during the week, you will be learning 2 lessons from 2 ends, right? That is how this goes. You will be learning 2 lessons from 2 ends. Now, today and on Wednesdays, you are starting the things from the beginning, right? From the beginning side, and on Fridays, you are learning something that is towards the latter part of mechanics, right? So once everything is connected, ultimately, you are going to finish this program as a complete product, as you know, all mechanics from A to Z, right? That's the whole purpose. That is the whole purpose of this, right? And since few inquiries came about enrollments even today, and I know some of you have already enrolled to the program, and for others who didn't enroll it, I'll quickly explain how the enrollments are going. Another thing about the tutes, since it is a fully online program, I'll be delivering the soft copies of tutes, right? I'll be delivering you the soft copies of tutes only, right? Usually in my other theory classes, hard copies are delivered, but here, since it's a fully online program, and that we need to do things kind of a faster manner, right? Most probably you will get a weekly tute, right? Most probably you will get a weekly tute. So therefore, it is not that possible to deliver tutes weekly. So therefore, we'll stick to soft copies. If you need a hard copy, what you can do is I'll be sending you the PDF. So if needed, you can take a hard copy. And if you are comfortable with the soft copy of the tute, you can go that way, right? Now, since you need to take a hard copy, since you need to take a printout, I'll be uploading the tute like around 3 days before the class starts. Then you have enough time to take the printout, take the hard copy if you are in need, right? So usually that is how it is going to happen, right? That is about the tutes. Okay. And the other thing is the enrollment. Enrollment is like this. You have to enroll on the website. Website is this. So you can just visit the website, and easily you can create an account, right? Visit there, and then you will see the ongoing classes on the home page, right? So if you haven't created the account, first you can create the account, enter your basic details that is asked there in that starting page, and create your account, right? I'll send all your details and all these registration details to your group, to the BOUNCEBACK group, right? You can create your account. Once the account is created, you can enroll to the particular class. So you will see all the available classes on the website. There you will see the BOUNCEBACK class, right? You will see BOUNCEBACK. Go to BOUNCEBACK, right? Once you go into bounce back, you will be asked about an enrollment key. I'll send you the enrollment key for the program, right? You can enter that enrollment key, right? You can enter that enrollment key. This is the key actually. Enrollment key is this. Capital P simple S at capital P HY capital B capital B M. This is the enrollment key. So once you enter this enrollment key, you will be enrolled to the class. So once you enroll to the class, once you go into the class, you can see the respective month. Now, as an example, if you enroll to the class and if you go in, you will see the month of November, and you can see the weeks like week 1, week 2, week 3, week 4, likewise, right? So there now, since today is a free day, I shared the link in all groups, right? I shared the link in all groups. But next week onwards, once you are enrolled to the class, joining the class can only be done using website only, on the website only, right? So therefore, that's a very easy one. You can just go there. Let's say now next week is week 2 now. Go into week 2. Under week 2, you will see a button as join class, right? Click on that button, then you will be joined to the class, right? Something like that. Now, about making payments also, that is on the same website, right? Once you go into the month, you will see a button as monthly payment, right? Now it is November, you will see a button as monthly payment November. Just go into that button, then there you will see all payment details. Once you do the payment, you can upload the slip there at the same place, and you can submit it. Once you submit it, that payment will get approved. Once it is approved, you can join the rest of the classes, right? Something like that. So therefore, make sure you are creating the account and completing your enrollment on website before next week, because after next week, joining the class can only be done on the website only. And the other thing is about recordings. Some of you asked about recordings. Recordings will be provided. Provided in the sense, recordings are available 24 hours after the class is finished on the website, right? Now, which means, let's say now we are going to finish the class today at 10 p.m. Tomorrow by 10 p.m. recording will be available on the website. Under the same week, right? That's a very convenient thing you have there. Right? Just go into the week. Then after 24 hours of the class, you will see the recording, right? Then if you need to watch the recording, what you can do is, so with that recording, you will see a small button as request recording. Just click on that request recording button and make the request. Once the request is made, that request will be approved, and once it is approved, you can watch the recording like as many times as you need during 7 days. Right? Which means now today's recording, if there is today's recording, if we finish the class by 10 p.m. today, will be available on the website at 10 p.m. tomorrow, and it will be available on the website for 7 days, 7 complete days, starting from tomorrow, right? Now tomorrow is Thursday, no? So until next Thursday 10 p.m. exactly 7 days. Next Thursday 10 p.m. it will be available on the website, right? So you can watch it anytime as you need, right? Even if you miss the class, or if you are in the live class, or if you need to, even if you're in the live class, if you need to go through the recording again, that is totally fine. You can request the recording and you can get it and watch it until you get familiar with the things, right? But it will be available only for 7 days on the website, right? Automatically it is going to expire after 7 days, right? So therefore, make sure you are watching the recording during 7 days, within 7 days, if you miss the class, right? Okay, so that is about recordings. Those were the questions some of you like frequently asked. So I think I have answered all the questions now you have asked. So is there anything that you need to clarify further before starting? Any other thing that you need to clarify further before starting? So you can ask your questions on chat boxes. Once on Zoom, you can put your questions there, and the others on YouTube, you also can put your questions to the live chat so I can see. All right. So any questions before starting? Is there any questions before starting? Oh, is it all clear? Tell me. You are joining BOUNCEBACK program because you have missed mechanics somehow when you are doing in the theory class or school or somewhere for the first time. So therefore, now don't hesitate to ask questions. Always ask questions and clarify things you have, because don't do the same mistake you have done before in the first time. Don't do the same mistake again. Now you are here because of you missed the lesson for the first time. No? So therefore now you have to put the effort, you have to put your fullest effort and do this here in an effective manner. Okay, any questions? Is it all clear? Clear. Good. What about the ones on YouTube? Any questions? Ask if there's anything to clarify. What about the ones on YouTube? Anything to clarify from your side? Okay, it seems no. Then we'll start the program. We'll jump into the program. Right. So today, and listen. Before that, and because of this bounce back mechanics program, now I'm going to cover the lessons with a special plan and a special order. Sometimes it won't be the same order that you have the lessons in the syllabus, right? Sometimes I'll be covering the lessons kind of a different order for you to understand some parts better, like even better. So therefore, in some cases we will be all good to you. All right. So in some cases, right, we'll be changing that order. I'll be changing that order, right? So today my plan is to start from the beginning, linear motion, but at some points, at some places, we'll be changing. I'll be mixing the order for you to understand some things better, right? So therefore, this is not going to be a traditional mechanics class, a mechanics program, right? We'll be doing the things based on and focusing on grabbing it faster, right? For the purpose of grabbing it faster, got it? Understanding it faster in a clear manner. That's the whole purpose. All right. Now, without further ado, let's start. Okay. Take down the heading as mechanics, and under that, linear motion. Take down the heading as linear motion. Linear motion. Right. Give me 2 minutes. Someone says there's a small blur kind of a thing on the YouTube one. Let me check. Give me 2 minutes. Give me 2 minutes. I'm just checking on my software. Okay, what about now? Now it's more clear, right? Okay. All right. All right. So about linear motion. My first question. Now, always when I ask a question, engage with me and please do respond. Right. Now, since it is the starting day, there are students on both Zoom and on YouTube. Right. So wherever you are, once I ask a question, please respond and express your thoughts, because then I know where you are and I have an idea from which point should I start explaining and at which point should I stop explaining, right? So likewise, I can get an idea about how you are doing, right? Especially I can arrange myself, I can adapt myself with the explanation based on your understanding. So therefore, if I ask a question, please make sure that you respond. If that is clear, at least with a reaction, at least try to respond, right? So likewise, try to be like interactive here. Then we can make this teaching and learning environment kind of a better interface, right? Because now this totally an online classroom. That's the thing. All right. So tell me, what do you know about linear motion? What do you know about linear motion? Yeah, now it's clear. The thing was with the streaming software, I guess. Yeah. Now it's fine. Now it's totally fine. Okay, thanks. What do you know about linear motion? What is linear motion? Simply, what is linear motion? Quickly, what is linear motion? Motion of an object takes place along a straight line. Exactly, yes, correct. Right? Linear means if any object undergoes a motion on a straight line, a linear path, that is called a linear motion. Right? Very simple as that. Now, in this program, right, I'll be always explaining everything starting from scratch, as every one of you can understand. Right? In which level you are, doesn't matter, you will understand it. Right? But yet, if you didn't get something, always feel free to ask questions. Okay, write down on the topic as a first point. Write down, if an object travels write down, if an object travels along a straight line, if an object travels along a straight line, it is called a linear motion. If an object travels along a straight line, it is called a linear motion. If an object travels along a straight line, it is called a linear motion. Right. Look at here. Now let's say, look at the board. Now let's say this is an object. Let's say this object is at here at t equals 0. T equals 0 is the point where we start measuring time. Right? T equals 0 is the point where we start measuring time. the point where we start measuring time, right? Now, if we are studying about motion, right, we should have a point where we are starting to prefer time. We are starting to start time. That is called equal zero of a motion, right? Now, since it is a linear motion, this object will undergo along a straight line like this. This object will undergo along a straight line like this. Let's say this object is here after t equals t for time t. After time t, the object has moved from A to B. Let's say the object has traveled from A to B after time t. So at this point, let's say there was no velocity for the object. There was no velocity for the object. But at this point, the object has gained a velocity of v. But at this point, the object has gained a velocity of v. Right? Now, since there is a change of velocity, initially velocity was 0, and now finally velocity is v. There is a change of velocity. We call change of velocity as acceleration. We defined acceleration as change of velocity. That is actually rate of change of velocity, right? If there is a change of velocity, a rate of change of velocity during a particular time interval, a given time interval, that is called an acceleration, right? So since velocity is changed from 0 to v, which means the object has accelerated. Which means the object has accelerated. That has accelerated. So let's consider that acceleration as a. Let's consider that acceleration as a. Now, if an object travels from A to B, right? If an object travels from A to B, if the object has traveled from A to B, for sure we know the object has changed the position. The object has changed the position. If the position is changed, which means object has displaced. If the position is changed, which means the object has displaced. It is displaced from one point to the other. It has changed the position. So therefore, from this point to that one, from A to B simply, from A to B, look at the board, from A to B, the object has displaced. Let's say the displacement is S, right? So likewise, now when we explain about a linear motion, those are the parameters involved. Those are the parameters. What are parameters? Parameters are variables. Those are the variables involved. Those are the parameters involved. Without knowing parameters, we can't explain about a motion, right? This is not only valid for linear motion, this is valid for any type of a motion. Without knowing parameters, how can we explain the motion? Now, if I need to say that the object accelerates from A to B and it covers a displacement S and it has changed the velocity from 0 to V, right? So likewise, we have to use parameters. Something like this. Say you need to explain about this pen. Listen, you need to explain about this pen. What are the possible parameters you can use when explaining about the pen? Tell me. Engage answering. What are the possible parameters you can use when we are explaining about this pen? Tell me. What are the possible parameters? Mass, correct. Yeah, we can explain this from the mass. Yeah, mass of this pen is 20 grams. So that is an explanation. What else? What about the others? Set me the Minari. Yeah, we can explain about the length. Correct. What else? Color is also parameter. Color is also parameter. Right? Diameter, right? Length is also correct. Diameter. So likewise, now when I try to explain about this pen, there are some parameters to be used. So likewise, when we are trying to explain about a linear motion, there are parameters to be used, right? So those parameters are called parameters of linear motion. Now as examples, see, time is a parameter, displacement, linear displacement is a parameter, initial velocity, final velocity, linear acceleration, they are parameters. So those are the words, those are the variables that we need to stick to when we are explaining about the motion. They are called parameters, right? Okay. As the next subheading, write down parameters of linear motion. Write down parameters of linear motion. Parameters of linear motion. Parameters of linear motion. Parameters of linear motion. Okay, then take this down. Take down the diagram. Take down this diagram. Right. Okay, now write down parameters one by one. Write down these parameters one by one. First one, initial velocity. Initial velocity. We denote by u. Then final velocity. We denote it by v. Then linear acceleration. We denote it by simple a. Then linear displacement. We denote by s. And finally, time. Time is actually time interval. We denote by t. Take it down. Right. Okay, now listen. Based on these 5 parameters of a linear motion, there are 4 linear motion equations introduced. Right? Based on these 5 parameters, there are 4 linear motion equations introduced. So here in physics, we don't prove those equations, but if you are doing maths, if you are a combined math student, right? So probably you will prove all 4 linear motion equations. Since there is no need of proving the equation, we won't be proving it here, and we'll be moving forward. As the next heading, write down linear motion equations. Next heading, linear motion equations. linear motion equations. Linear motion equations. Right. Look at here. Based on these five parameters, four equations are introduced. Right. First, we will see what these four equations are, and then I'll explain you how to apply this equation. Right. Once you know about the application, straight away we will start some questions, and that is where you are going to start the calculations today. You are going to start sums today. Right. So we will see how to apply these equations first. Right. So first thing is knowing the equations. Okay. See, first equation is V equals U plus AD. Right. And then S equals UD plus half AD squared. S equals UD plus half AD squared. Then V squared equals U squared plus 2AS. Then S equals V plus U over 2 whole thing into D. These four are called kinetic equations or linear motion equations. Kinetic equations or linear motion equations. Right? And all the meanings of these equations are here because these are the parameters which place in these equations, right? Which drives these equations. So therefore, now learning outcome of this part is you should know all the linear motion parameters and you should know all these four equations to use it where necessary, right? So learning outcome just from this part is knowing linear motion parameters and knowing all four linear motion equations. Okay, first take it down. Take it down. Take it down. Okay, listen now. Listen now. So about these four equations, the first thing is all these four equations are vector equations. Vector equations means these equations can be applied along a considered direction, right? They are vector equations. Therefore, these equations can be applied along a considered direction, right? Since they are vector equations, all basic rules regarding vectors are valid. There are four basic rules regarding vectors. For linear motion, only three will be used. So therefore, I'll explain the three rules that we are going to use in linear motion, and you will see all four in the next part, projectile motion. And actually, again, you will be seeing vectors. You will be seeing these laws in vectors when you are covering the vectors as well, right? First thing, since they are vector equations, they are applicable only along a given a chosen direction only, right? A given direction only, a chose direction only, right? Therefore, this is how the rules are going to be. All the vectors which are acting to the same direction that I consider, that I chose, is going to be plus. They are considered as plus, right? And all the vectors which are acting opposite to my considered direction are considered as minus, right? And vectors which are acting perpendicular to my considered direction are going to be neglected. They are neglected. They are not considered at all. They are neglected, right? And the fourth rule is about the inclined vectors. Since we don't have inclined vectors in linear motion, I'm not going to explain that now because I don't want to put more weight onto your head on the first day itself when you are learning this from the start, right? So likewise, you will see these things step by step, and by the end of this program, you will understand everything better, right? Okay, with a red pen, mention these points below equations. Mention these points in a red pen below equations with a red pen. Mention these points with a red pen. First point, all linear motion equations are all linear motion equations are all linear motion equations are vector equations. Vector are vector equations. Vector equations. Right? Vector equations. Next point. Next point. Therefore, all basic rules regarding vectors. Therefore, all basic rules regarding vectors. All basic rules regarding vectors are applicable. Are applicable. All basic rules regarding vectors are applicable. Sorry. All basic rules regarding vectors are applicable. Okay. Mention below that. Now I'm going to mention about the basic rules of vectors. If you have a different color other than red, you better use that color. First bullet point, write down vectors acting along, vectors acting along, vectors acting along, vectors acting along, consider direction, vectors acting along, consider direction, vectors acting along, consider direction, are considered as plus. Vectors acting along considered direction are considered as plus. Are considered as plus. Plus means positive. Plus, positive. Second point, vectors acting opposite to considered direction. Vectors acting opposite to considered direction vectors acting opposite to considered direction, vectors acting opposite to considered direction are considered as minus, are considered as minus. Negative, minus means negative. Vectors acting opposite to considered direction are considered as minus. Vectors acting opposite to considered direction are considered as minus. Next one, vectors acting perpendicular to considered direction. Vectors acting perpendicular to vectors act in perpendicular to considered direction. Vectors act in perpendicular to considered direction are neglected. Are neglected. Okay. Right here. Right. I'm going to show you an example. Write down this way. I'm going to show you an example. Write down this way. Let's consider. Write down. Let's consider. Let's consider. Let's consider an object starts motion. Let's consider an object starts motion at rest. Let's consider an object starts motion at rest at point A. At rest at point A. At point A. Gains a velocity. Gains a velocity. Gains a velocity. Gains a velocity 10 ms minus 1. Gains a velocity 10 ms minus 1 after 4 seconds. Gains a velocity 10 ms minus 1 after 4 seconds. And coming back to rest 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 after another coming back to rest after another coming back to rest after another 2 seconds. Coming back to rest after another 2 seconds. Coming back to rest after another 2 seconds. Okay. Then take this down. This object start the motion at 0, at rest. Rest means 0, from rest. And it has moved. Now this 3 equals 0. So we know that this is 3 equals 0. And it has moved from A to this point for 4 seconds. Then t equals 4 is here. T equals 4 is here. And it has gained the velocity now. The value is 10 ms minus 1. It has gained a velocity. And then again this object is going to be stopped here. Again this object is going to be stopped here. If there is a stop, we know this velocity should be 0 again. And the time is given after another 2 seconds, which means total time here is 6 seconds. Take this down. Total time is 6 seconds. Okay, take it down. Okay, listen. Now we are going to find few parameters about this motion, right? As a first example question, right? We are going to find few parameters. Parameters means variables. Okay, as number one, write down. As number one, write down. Label these points as A, B, C. Right? As number one, write down acceleration from A to B, write down acceleration from A to B. Okay, look at here. This is how we are doing this. See. So listen carefully, and this is a very easy thing. Try to grab this at once, and then hereafter we will do all other coming up questions like hassle free. Okay. First thing is, when we are applying a linear motion equation, we have to have a section, right? We have to have a section, and then you have to have a direction. Since I need acceleration from A to B, the section I'm going to select is A to B, right? So therefore, this is written as from A to B. See, from A to B, and you have to mention the direction. Since direction of motion is to the right, I'm going to consider the rightward direction. Then check what is known and what is required. I need acceleration. Times are known. Initial velocities, final velocities are known. So therefore, I'm going to go ahead with V equals U plus AD. See, then rightwards, V equals U plus AD. Right? Now, always the final velocity and initial velocity is with respect to the section you have considered. Which means now when I consider the section from A to B, my initial point is point A. Right? My final point is point B. So therefore, initial velocity refers to point A. Final velocity refers to point B. Right? That is how it goes. You can apply the equation only for a selected section. Right? So from this section, this is going to be my initial point. This is going to be the initial point. And B is going to be the final point. B is the final point. Right? See, we need V. Now B is my final point. V is final velocity. Then V is the velocity at B, that is 10. U, initial velocity. My initial point is A, so velocity at A is 0. Plus, I need acceleration. Acceleration into time interval. Time interval is 4. Right, simplify this. 10 equals 4A, A equals 2.5 ms minus 2. A equals 2.5 ms minus 2. Right? So acceleration is determined. That is how you should apply a linear motion equation. Got it? We have to have a section and a direction. And then we can apply the equation. Right? Take it down. So likewise, now in this first example question, you will be seeing the application, and from this question itself, I will be giving you the full idea about how the equations are applied. Okay, see. So what if we get A subjected and use the equation? No problem, no problem. But usually we don't subject and substitute because when there are cancelling terms, sometimes just after the substitution it will cancel. So therefore, no need to spend time just to subject it from the equation. We can do the subjecting while doing the simplification, right? That's why, otherwise there's no difference. Otherwise, no difference. No difference. Okay, see, next thing, number 2. Look at here, number 2. Now I'm going to find the distance between A and B. I'm going to find the distance between A and B. Another parameter. Another parameter. Now, some parameters are known and some parameters are unknown. Right? Using equations, we are going to find these unknown parameters. Using equations, we are going to find the unknown parameters. That's the thing. That's the thing. Okay. Write down number 2, Rome number 2, as Rome number 2. As Rome number 2, write down. Distance covered between A and B. Distance covered between A and B. Distance covered between A and B. Okay, now if I need to find the distance from A to B, right? Distance from A to B, we have to apply an equation from that list which has displacement on it. Right? Distance from A to B means there is a linear path. No, there is actually the displacement. Right? Displacement. Now, what are known? Time is known. Multiple options are also available. Now, time is known. Velocities are also known. Right? Multiple options are available. Right? See, simply what I can do is, again, if I need the distance from A to B, choose your section from A to B. From A to B. To the right. See, I am going to apply this equation. S equals UD plus half AD squared. S equals UD plus half AD squared. S is displacement from A to B, let's say SAB. U is 0. U is 0, so UD is 0. Half, acceleration is determined here, 2.5. 2.5. T squared, T is 4, which means 4 squared. Time interval is 4, no? 4 squared. Simplify this. Simplify this. So I'll write this as 2.5 is 5 over 2. No? Half times 2.5 means 5 over 2. And this is 4 times 4. See, 2 times 2 is 4. So it cancels. SAB equals 20 meters. So distance between A and B is 20 meters. Distance between A and B is 20 meters. 20 meters. Correct? Without doing this, we have more options as well. Now, for you also, if you have tried in a different way, different manner, that is totally fine. But whatever the equation you used, if your application is proper, if your application is correct, you will end up getting the same answer, exact same answer. Right? So without doing this, if you apply this equation also, this is also an option. Again, from A to B. From A to B, rightwards. From A to B, rightwards. If you apply an equation like V squared equals U squared plus 2S, that is also possible. That is also a possible option. V squared is 10 squared. U squared is 0 squared, that is 0. Plus 2 times acceleration. Acceleration is 2.5, that is 5 over 2. No? Times S. S is distance from A to B, SAB. Right? Simplify this. 10 squared is 10 times 10 equals this 2 to 2 cancels. 5 times SAB. 5 times 2 here. 10 times 2 is 20. So SAB is 20 meters. So that's what I told you. Either way, one way or the other, you will get the same answer as long as your application is correct, as long as your application is proper. Right? That's the thing. Take it down. So your method will be, sometimes it might be different from both of them. If you have applied the equation like S equals V plus U over 2 times C, that is also possible. Either way, you will get the same answer. Right? Take it down. Take it down. And ask your questions if there's anything. Okay, let's see. Let's move on. Let's move on. So there are more options, right? So if you can think of another equation, you can apply, right? So that is how it goes. So always try to think based on what is given. Next, as row number 3, write down row number 3. As row number 3, write down deceleration between B and C. Deceleration between B and C. Deceleration between B and C, and give it a try. Give it a try and send me your answers. Tell me your answers. 5ms minus 2. Good. Let's see. Others? Okay. So what we can do? Apply. Time is known. Velocities are known. So I'm going to apply V equals U plus AD from B to C. See, from B to C, rightwards, V equals U plus AD. Right? V equals U plus AD. And now, according to my section, these points changes. Now in my section, B is the initial point. Now B is the initial and C is the final point. So likewise, based on the section, it changes. B is initial now, right? Then initial velocity now you can't take 0 as initial velocity because my section is B to C, right? So final velocity at C. It is 0. See, it is 0. Initial velocity at B. That is 10 to the same direction. Plus 10. Plus A, T, time interval, 4 to 6, 2. Okay, now when this is taken to the other side, minus 2A equals 10. 2 and 10 cancels, which means A equals minus 5ms minus 2. Right? So always you will be getting the answer along with the sign when you deal with vectors. Always you will be getting the answer along with the sign, along with the signage when you deal with vectors. So that is why it is coming as minus 5. That is a verification that it is a deceleration. That is a verification. It is a deceleration. Take it down. Take it down. Right. Mention this with a red pen. Mention this with a red pen below this thing with a strict mark like this. Mention this with a red pen. Answer comes along with sign. Answer comes along with sign. Answer comes. Answer comes along with sign. Answer comes. Answer comes along with sign. Answer comes along with sign. Answer comes along with sign. When dealing with vectors, answer comes along with sign when dealing with vectors. Right? So this is a common thing for any vector. Always it comes with the sign. Always the answer comes with the sign. So therefore, even if you know that it is a deceleration, don't plug minus sign there. Don't substitute the value with the minus sign there and let it come. Let it come. Right now, before applying from B to C, for sure I know there is a deceleration because velocity has decreased from 10 to 0. Right? So therefore, for sure we know there is a deceleration, but yet don't plug that A with a minus sign, with the minus sign as minus A. Let it come and then you can verify whether it is actually a deceleration or not. Right? That is the safe approach and that is a better approach. That is actually the recommended approach. Okay. 4. Write down 4. Distance between B and C. Distance between B and C. Give it a try. Distance between B and C. Distance between B and C. Right. 10 meters. Others? 10. Good. What you can do? Again, multiple options are available. Right. I'll be using from B to C, I'll be using V squared equals U squared plus 2S. Right. You can use any equation that you prefer. Totally fine. Totally up to you. Right. V squared. Final velocity at C is 0. 0 squared is 0. U is 10. So 10 squared. Now A is known. A is minus 5. So when you plug this value here also, you have to plug along with the minus sign. You have to plug along with the minus sign. Na? You have to plug along with the minus sign. Minus 5. SC is SBC. Distance from B to C. Right? Take this whole thing to the other side. 2 times minus 5 is minus 10. No? Then here it becomes plus 10. Plus 10 SBC equals 10 squared. 10 squared is 10 times 10. So 1 10 cancels. SBC equals 10 meters. Right? So likewise, when you are using these values again, wherever in the substitution, you have to make sure that you are plugging that value along with the respective sign. That is 10 meters. 10 meters. Right. Understood? No? 5. 5. 5. 5. Total distance between A and C. 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 Very straightforward. Very straightforward because these two distances are already known. Distance from A to C equals, see, distance from A to C equals distance from A to B plus distance from B to C. No? So this was 20 meters and this is 10 meters. So that is 30 meters. 30 meters. 6. Right? They are simple ones. Right? So we can quickly move on. 6. 6. You all will get the route next day, right? You all will get the route next day, right? And next day we'll be spending the full day with the questions from the theories that you are learning today. Now today also, while learning theories, we are practicing questions like this. But next day it will be a full day of linear motion questions that you are learning here, right? So most probably you will get 2 routes for calculations and the other things. Let's see. Right. Next 6. Average velocity of object. Average velocity of object. Average velocity. Average velocity. Okay. So anyone tell me what is the equation of average velocity? If you know. What is the equation of average velocity? Tell me. What is the equation of average velocity? For average velocity, there's a particular equation. What is it? What about Mosadi? What is average velocity? Any idea? Sasana, total displacement dot total time taken. Yes, correct, good. Total displacement dot total time taken. Yes. Okay. So find it out. Find it out. Applying the equation. Average velocity is, that is correct. Average velocity is total displacement. Total displacement over total time. If you are asked to find average speed, this changes as total distance over total time. Right? Total distance over total time. Total displacement is here 30. Total time is 6 seconds. So average speed is 5 ms minus 1. Average speed is 5 ms minus 1. Right? Average speed is a generalized speed for this entire motion. Right? 5 ms minus 1. Okay. Understood? So any questions from this example? Is it all clear? Any questions from this example? Yeah, good. What about others? What about others? Is it all clear? Okay. Right. Okay. So let's see another example. Next. Okay, next. Okay, take this down as a question. Write down. Write down. Write this down as a question. An object is projected vertically upwards. Write down. An object is projected vertically upwards. This is a question. This is a question. An object is projected vertically upwards with a velocity vertically upwards with a velocity 50 ms minus 1. An object is projected vertically upwards with a velocity 50 ms minus 1. ms minus 1. Okay. Problem number 1. Problem number 1. Write down. Time takes to return back to ground. 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 Number 2. Maximum height reached by the object. Number 2, maximum height reached by the object. Next one. Time difference between time difference between two instances. 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 The object passes 100 meters from ground. Time difference between two instances. The object passes 100 meters from ground. Okay. Okay, that's it. That's it. Try to take down the diagram. Try to come up with your diagram. Not take down. Try to come up with your own diagram for the given case. I'll help you out because it's a first vertical motion you are going to consider. Right? A vertical motion under gravity actually. See? So give it a small try. Give it a small try. The object is projected vertically upwards from ground with a speed 50 ms minus 1. Right? So it will reach up to some maximum point and it returns. It will reach up to a maximum point and it returns. Right? Something like this. So once it is projected upwards, see? Once it is projected upwards, it is reaching a maximum point and it returns back. It comes back. Reaching a maximum point and comes back. Correct? Reaching a maximum point and comes back. Right? So even though it happens on the same line in reality, for the ease of identifying two sides, we are keeping a small gap in between and drawing this. Right? That is why this is drawn. And if an object has a maximum point, listen, if an object has a maximum point, which means it doesn't go beyond that point. That is what is meant by maximum point. No, it doesn't go beyond that particular point. That is because there is no velocity to go beyond that point. There's no velocity because, listen, if there's a velocity for the object, it should travel. Having a velocity, an object cannot be at rest. No, having a velocity, an object cannot be at rest. So therefore, if object is not moving, if an object is not moving further compared to a given point, a particular point, which means there is no velocity at that point. That is the idea. So therefore, there is no velocity for the object at the maximum point. So velocity at this point is going to be 0. Right? Velocity of the object at this point, maximum point, is 0. Right? So those are the given things and the things we used, arguments we used, considering the maximum point. And other than that, listen, any object which travels under gravity, see, any object which travels under gravity experiences gravitational acceleration. Therefore, throughout this motion, gravitational acceleration acts. Right? if there's any object which travels under gravity, just under gravity, right, like this, no any contact, no any surface, a motion under gravity, any such object undergoes gravitational acceleration. Direction of gravitational acceleration is vertically downwards. Direction of gravitational acceleration is vertically downwards. Okay, now give it a try. I'll give you 2 minutes before I start. Try it. Now, if you are able to complete the question before I do the discussion, right, which means you have grabbed this thing from the very first question itself, very first example itself, right? That is better, no? Try it, give it a try. Okay, let's see what your answers are. $250 on say, and 10 seconds. So first one 10 seconds to 250. Okay, when finding total flying time also, there are different methods. So you can choose any method. Okay, so let's see the first one, total flying time. For total flying time, this is what I'm going to do, right? At once, see now, for the sake of applying from section to section and to introduce sections, but we have to introduce a labeling. That is up to us. So therefore, you can use any labeling to introduce these points, special points, the required points. I'll be using ABC. Say this is A, maximum point is B, and this point is C. Okay. So if I need total flying time, first one, total flying time, we can use an equation from A to C at once. From A to C at once, upwards, an equation like S equals UD plus half AD square. Right? Another possible option is you can use one equation from A to B, another equation from B to C, and get the times and get the addition. That is also fine. But at once, I'll be using S equals UD plus half AD squared all the way from A to C. So if there is coming back to C, which means there is at the same horizontal level, no vertical displacement. No vertical displacement between A and C points, no, at the same level. So that is 0. This is 0. U is 50. We need time, T. Now here important, I'm going to use the equation upwards. See, this is an important point. I'm using the equation upwards. But gravitational acceleration is downwards. But gravitational acceleration acts downwards. Therefore, this should be plugged as minus G. This should be plugged as minus G, that is acting downwards. P squared. Okay, minus into anything is, now this minus half G squared, no? Take it to the left hand side. Then it becomes plus half G is 10, T squared is 50T, 1T to T cancels, right? Then 0 to 0 cancels. T equals 5 times 2, 10 seconds. T equals 10 seconds. Right? Yeah, it is correct. I saw the correct answer on the chat box. 10 seconds, correct. Ten seconds. Okay, then I asked about the maximum height, right? Maximum height. Maximum height occurs between A and B. Maximum height occurs between A and B. So I'll label it as H. What can we do to find maximum height? From it occurs between A and B, no? Then from A to B. Use the equation from A to B. What is the possible equation to be used? Upwards. V squared equals U squared plus 2S. V squared, velocity at B is 0. 0 squared is 0. U is 50. So this is 50 squared. Plus 2, we are using the equation upwards, while G is acting downwards, minus G, H. Take this term to this side, 2GH. G is 10, H equals 50 times 50. 50 squared. Right? 1 0 to 0 cancels, and 2 times is 25. H equals 5 times 25, 125 meters. 125 meters. Right? Mention this point in red. 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 G should be substituted. G, simple G. Simple G should be substituted. Simple G should be substituted. Simple G should be substituted. Substituted along with a minus sign. Along with a minus sign. G should be substituted along with a minus sign since it acts opposite to considered direction, since it acts opposite to considered direction, since it acts opposite to considered direction, since it acts opposite to considered direction. Okay, next one. Time difference between the 2 points, right? 2 instances, it passes 100 meters. Think and give it a try. So 100 meters is somewhere here, because total height is, maximum height is 125. So 100 meters is somewhere here, right? 100 meters is somewhere here, like this. 100 meters is somewhere here, right? So 2 instances are, when the object is moving upwards, also it passes 100 meters. And when it is coming back also, it passes 100 meters, isn't it? When it is moving upwards also, it passes 100 meters. And when it is coming back, in the returning motion also, it passes 100 meters. Those are the 2 instances I am referring about. So these 2 are the 2 points. These 2 are the points. Now since these 2 are 2 special points now, I'll be labeling it. Say D and E. D and E. D and E are the 2 instances. The object passes 100 meters. Think about it and do something and try to find the time difference. And the time difference between these two. Time difference between these 2 intervals. These 2 points, instances. Anyone? Anyone? Any answers? Any answers? Somehow we need to find the time interval between these 2 points. Time interval between these 2 points. Okay, let's say this is how I'm going to think about this. See, since D and E are at the same level, listen, since D and E are at the same level, if I can apply an equation like S equals UD plus half AD squared from D to E, having vertical displacement 0 because they are at the same level now. Vertical displacement is 0. So directly I can get the time difference because time takes from D to E is the difference of the 2 points, 2 instances, it passes 100 meters now. Right? Time takes from D to E. So therefore my thinking is to apply an equation directly to D and E from D to E, from D to E. So therefore I will need the velocity of object at point D. I have to have the velocity of object, speed of object at point E. Oh, sorry, at point D. At point D. Right? So what do we know about point D? That is 100 meters above. That is 100 meters above. Right? So if that is known, using an equation, so first I can find out the velocity at D. Right? So let's try it out. Time is unknown yet. So if needed, you can find the time and do the same thing as well. Now here my target is finding velocity at D. So let's assume the velocity at D as x. Let's say velocity at D as x. Now my target is to find x from A to D. From A to D. If I use an equation like v squared d equals u squared plus 2as, we can get something now. We can get something if we do this, right? V squared is going to be x squared. Final point is D now, x squared. U squared is here 50 squared. Using the equation upwards, G is downwards. So this is minus 2, G is 10, H is 100. Isn't it? Right? So what's happening now? X squared equals 50 squared is 2500 minus what is coming here? This is 1000. So here 2000 comes. 2000 comes. 2000 comes. Right? 2500 minus 2000 is 500. X squared is 500. X squared is 500. So x is root 500. It can be written as 5 times 100. No? So x is 100 is a perfect root 10, then 10 root 5. Right? I'll keep this as it is here. Finally, we will do the simplification. So velocity at x is 10 root 5. Velocity at x is 10 root 5. That is known. 10 root 5. Right? If that velocity is known, now my second approach is applying the equation from D to E. Right? So that is what I'm trying to do. Applying the equation from D to E. See? From D to E. Then from D to E, vertically upwards, S equals UD plus half AD squared. S equals UD plus half AD squared. S from D to E is 0. Same vertical, same horizontal level. U is x. U is x now. Xt applying upwards, so that is minus g. I took that minus sign to the front at once. Minus g t squared. Take this whole term to the left. Half g t squared. G is 10 t squared. X is here 10 root 5. 10 root 5 t. Right? T to 1 t cancels and 10 to 10 cancels. T equals 2 root 5 seconds. T equals 2 root 5 seconds. This can be simplified. We know root 5 as root 5 is 2.23. Root 5 is 2.23. Right? For A-level physics, you have to keep these three roots in your mind, right? These are very popular roots we are using in questions. So keep these three in mind if you don't know. These are the roots we need for physics. Root 2, root 3 and root 5. Root 2 is 1.41. Root 3 is 1.73 and root 5 is 2.23. Right? So likewise, we have to use them at once without checking logs, without going into log tables. That is a purpose. That is a purpose. Right? So t equals 2 times root 5. That is 2.23. So time difference equals 4.46 seconds. That is the final answer. 4.46 seconds. Right? A little bit different idea. A little bit different idea compared to the first one, compared to the first question. Kind of a different idea. Take it down. And if you got any questions, please do ask. What about the question? Is it all clear? Right? Right. So this part 3 is is kind of a different part and an important part, right? So grab the way that we thought about the question. We have to think in the question, right? Or else another option is, there is another option if needed. Yeah, another option is you can use an equation like S equals UD plus half a d squared from A to D, and you can try to find time it takes to reach D, right? You can try to find time it takes to reach D, right? When you try to find that time, since there is a quadratic equation, you will get two times. You will get two answers for the time. You will get two possible answers for the time. Those two answers will be the times at D and E. So if you get that difference also, the same answer will come. You can give it a try later using that method. That is also a possible option. That is also possible, right? Once you just trying to find the time takes to one point, if there are two possible points, Equation gives us both. That is how it works. Equation gives us both. Then you will get times at D and E. Say now, as an example, you got say 4 seconds up to D, and you got 6 seconds up to E. I'm just saying arbitrary values. Right? You got T as T equals 4 and T equals 6, which means at T equals 4, point D is passed. At T equals 6, point D is passed. So the difference is the difference. 2 seconds should be the time difference between these two instances. There is another option. There is another option. You can try that out too and check whether the same thing comes. This one, 2 root 5. You can try that way and check whether the same thing comes. Definitely it should come if your application is a proper one. Proper in the sense a correct one. Proper means correct. All right. Write down below with a red pen. Mention below with a red pen. Mention this below with a red pen. Velocity at maximum point. Velocity at maximum point. Velocity at maximum point. Velocity at maximum point is 0. Velocity at maximum point is 0. Next point. Next point. Times taken. Times taken. Times taken for first half. Times taken for first half. Times taken for first half. Times taken for first half and second half. Times taken for first half and second half of motion. Times taken for first half and second half of motion are equal in a symmetric motion. Are equal in a symmetric motion. Are equal in a symmetric motion. Okay, let's move on. Next. Take this down. Next question. Take down an object A, an object A, capital A, an object capital A, an object capital A starts its motion. An object capital A starts its motion at rest. An object capital A starts its motion at rest and travels with a uniform acceleration and travels with a uniform acceleration and travels with a uniform acceleration travels with a uniform acceleration of 6 ms minus 2, uniform acceleration of 6 ms minus 2. Another object capital B, another object capital B, another object capital B, another object capital B passes capital A. Another object capital B passes capital A. Another object capital B passes capital A. Passes capital A. Passes capital A with a constant velocity. With a constant velocity. With a constant velocity 20 ms minus 1. With a constant velocity 20 ms minus 1. Problem number 1. Problem number 1. Problem number 1. How long does it take? 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 How long does it take capital A to catch capital B? How long does it take capital A to catch capital B? How long does it take capital A to catch capital B? Number 2. Number 2. Number 2. Distance traveled by capital A. Distance traveled by capital A until catching point. 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 Number 3. Number 3. Velocities of each object at catching point. 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 Okay, that's it. See, now this is like this. There are two objects moving simultaneously at the same time. One object is object A. It is starting with 0. Initial velocity is 0 and travels with an acceleration 6 ms minus 2. Right? At the same time, now this t equals 0, no? At the same time, another object, at the same time, another object B passes A with a constant speed 20 ms minus 1. With a constant speed 20 ms minus 1. Right? And somewhere down the line, now both of them are moving towards the rightward direction. Somewhere down the line, at some point down the line, they are going to catch each other. They are going to meet each other. Right? Catching is also meeting. Catching means meeting. Right? They are going to meet each other. We don't know at which point they are going to meet. So let's consider a random point as meeting point somewhere here. Let's consider random point here as t equals c as their meeting point. Then, up to this point, capital B should move a distance from here to here, let's say SB, and capital A should travel a distance SA from here to here. Right? So once their displacements are equal only, they are going to meet each other, right? If their displacements are different, one will be shorter, right? If their displacements are different, one object will be shorter than the other one. But when their displacements are equal, they will be again at the same point. When they are at the same point, that is actually the meeting point. If they are at the same point, that should be the meeting point. Got the idea? So that should be the meeting point. That has to be the meeting point. Therefore, now clearly you can see from the diagram, their displacements are going to be equal now at the meeting point. Their displacements are going to be equal now at the meeting point. Right? That is the first argument I am going to use in this question. First, take this down. Take down the diagram. So, raise your questions if there's anything. Take down the diagram. Okay, listen now. Listen. Now, my argument is they are going to meet each other at the point where their displacements are equal. Right? So first write the argument. Write the argument. So you better use red pen and write the argument. A and B meet each other when A and B meet each other when A and B meet each other when SA equals SB. A and B meet each other when SA, displacement of A, equals displacement of B. A and B meet each other when SA equals SB. Right? A and B meet each other when SA equals SB. Right. Now, we can find SA and SB separately by applying two equations for A and B separately. Right? See, if I need SA, we can use an equation for A. Right? For A, now let's label these points as, I need these points to be labeled, say P and Q. For A, from A to B, from P to Q, right? S equals UD plus half AD squared. S is SA. U of A is 0. Half A is 6 T squared. So here SA equals, this cancels, 3T squared. I'll consider this as 1. Similarly, for B, from P to Q. Right? Rightwards, S equals UD plus half AD squared. Again. Right? SC is going to be SB. Right? U is 20. 20T. Times are equal for both now because they travel from T equals 0 to T equals T. But acceleration of B is 0 because it is clearly given that 20 is a uniform velocity. since 20 is a uniform velocity, there's no acceleration. It is 0, right? So this whole part becomes 0, which means SB equals 20t, right? We'll consider that as 2. Now, SA and SB are known. SA and SB are known. Plug it here and simplify. Plug it here and simplify. 3t squared equals SB 20t. 1t2, t cancels, right? So t equals 20 over 7. T equals 20 over 7, which means as a decimal value, sorry, 20 over 3, right? 20 over 3. 20 over 3. So as a decimal value, we can write this as 6.67 seconds. 20 over 3 seconds. 6.67 seconds. Which means after 6.67 seconds of motion, they meet each other. They catch each other. Right? Take it down. Take it down. This type of questions are called meeting questions. Right? So understand these types. So when the tube is given, you will see all these types, all these question types in the tube. Right? So therefore, understand these types here onwards. Okay, then try other two parts. Try other two parts. And when you are plugging this value somewhere again, when you are plugging the value 6.67, you better plug the fractional value. Right? You better plug the fractional value, because if something cancels off with the fraction, then you can let it cancel. So therefore, when you substitute the value again, use the fraction. Right? Okay, next. So what I asked was about distance traveled by A, no? SA. We have an equation here. SA equals 3d square. So directly you can use this equation. From 1. Now this is answer 1 for the first one. This is the first one. For second one, directly I can use 1. From 1, SA equals 3d squared. 3 times t squared, t is here, 20 over 3. So this is 20 squared over 3 squared. 20 over 3 squared, no? 130.68. That's it. Good. One 3 cancels. So this is going to be 400 over 3. No, right? 400 over 3, no? 400 over 3 is 133.33. Isn't it? Tarsana. Isn't it? So this is 133.3 meters. 133.3 meters. Isn't it? Check your simplifications and check mine as well. Next, velocities of each object at the meeting point. Velocities of each object at the meeting point. Right. For velocity, now we know I don't have any issue with B because B is a uniform velocity. Then velocity at meeting point of B will be same as 20. Will be same as 20. So only velocity I need to determine is velocity of A. For that, apply a separate equation. For that, apply a separate suitable equation. For A, from P to Q. For A from P to Q. We need V, no? V equals U plus AD. Let's say V equals U plus AD. Right? Say velocity of A at this point is VA. Then VA equals U is 0 plus acceleration is 6 and time taken is 20 over 3. Time taken is 20 over 3. This is 3 times 2. Right? 3 times 2. So VA is 40 ms minus 1. 40 ms minus 1. Right? Yeah, VA equals 40 and VB is a constant value. VB is a constant value. So therefore, VA equals 40 ms minus 1 and VB equals same 20 ms minus 1. So at the very next point, A will pass, A will overtake B. A will overtake B, A will pass B. Right, write down. Right. Okay, write down below with a red pen. Write down below with a red pen. Write down below with a red pen. Both objects should be at the same point. 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 Should be at the same point. At same time. Should be at the same point at same time. When meeting each other. When meeting each other. When meeting each other. Next point. Capital A overtakes B. Capital A overtakes B. Capital A overtakes B. Capital A overtakes B at very next point. Capital A overtakes B at very next point. Capital A overtakes B at very next point. Since velocity of A is greater. Since velocity of A is greater than that of B. Since velocity of A is greater than that of B. Since velocity of A is greater than that of B. Right. All right. Any questions up to here? Any questions up to here? Is it all clear? Okay. So for part 2, I use distance of B. Why have you used distance of A? The answer is not really of what it is same. It is same. That is totally fine. Because either way you will get the same answer because we know SA and SB are anyway equal, no? There's no any specific reason to use A. You can use either SA or SB. You will get the same answer eventually. Right? It will be same. Because for sure we know SA and SB are equal. Right? That's why. For sure we know they are equal, no? It's clear now, right? Mostly. Right. All right. Then as the next heading, write down linear motion graphs. As the next heading, write down linear motion graphs. We are covering all theories we have in linear motion today. Right? We are covering all the theories we have in linear motion today. So likewise, weekly we'll be covering the parts one by one in a faster manner, and we are going to recap all. Right. Linear motion graphs. Linear motion graphs. Right. So the respective part we are going to start is linear motion graphs. But before linear motion graphs, we have to have some knowledge about general knowledge about graphs. Right. So quickly I will recall what we need to know in terms of graphs here for linear motion graphs. Right. Take this down as a note. Okay. Write down first gradient of graph. Gradient. Write down gradient of graph. Gradient of graph. Look at the board. Now, if this is a graph plotted between y and x, right? So this graph is plotted between y and x, right? Gradient is, look at the board. Gradient is the tan value of angle, tan value of this measured angle with the horizontal, right? So therefore, gradient is defined as gradient. We call M. See, gradient. We denote it by M. Is defined as tan theta, right? Tan theta. And if this difference is delta y, right, difference of y values, and if this difference is delta x, difference of x values, right, we know tan theta can be written as opposite side of adjacent side, no? Tan theta can be written as opposite side of adjacent side. So therefore, this is also delta y over delta x, right? So there are only two ways that we can write the gradient. Those two ways are these two. So gradient can be written either as tan theta or delta y over delta x, right? And listen, if this theta is, if this theta is an acute angle, if this theta is acute, right, there is a positive gradient. If this theta is acute, there is a positive gradient. If this theta is obtuse, there is a negative gradient. Right. Take this down. Right. If this measured angle is acute, gradient is plus. If there is obtuse, gradient is minus. Simple as that. Very simple as that. Right. Finished? So as an next heading, write down gradient types. Gradient types. Okay, look at the board again. See? Okay, see? Now, when we are looking at a gradient, now we know gradient equals tan theta now. See? We know gradient equals tan theta. So when we are looking at a gradient, we are checking the angle, simply the angle, right? Always angles are measured in counterclockwise direction. That is a standard direction of measuring angles, right? So therefore, always angles are measured in counterclockwise direction. Counterclockwise. Angles are measured in counterclockwise direction, right? And if that angle is acute, we know there is a positive gradient. And if that angle increases with the line, with the curve, then when angle increases, tan theta increases. When tan theta increases, gradient increases. So if it decreases, tan theta decreases. So likewise, based on that, we are going to argue on these gradient types, right? I'll quickly explain like 2-3 gradients here, and you can try out how it works for the other types as well, right? Go to the first one. See, in the first one, the shape of the line is like this. Now, if I check the angle here, it is like this, and if I check the angle here, like this. If I check the angle here, like this. So you can clearly see this angle increases. This angle increases, but yet there is an acute angle. But yet there is an acute angle. So therefore, since there is an acute angle, this is a positive gradient. Since there is an acute angle, this is a positive gradient. Now angle increases. No? When this angle increases, tan theta increases. Therefore, m increases. Therefore, this is called a positively increasing gradient. So this is called a positively increasing gradient. Got it? This is called a positively increasing gradient. So likewise, we can check them all. Now, if I check it for the next one, this one, angle remains same at any point. This angle is same at any point. Since angle is same, we know they are acute angles. Since it is acute, that is positive. Since the value doesn't change, that is constant. So that is said to be a positive constant gradient. This is a positive constant gradient. So likewise, we can identify all these gradient types, right? And always this gradient follows the behavior of tan, because gradient is tan theta. It follows the behavior of tan. When tan values are minus, gradients are minus. So we know tan value is minus after 90. No? So that's why obtuse angles are negative gradients, because that's a tan value, right? Then if you check for this one, you will get positively decreasing. Here you will get negatively increasing. Here negative constant, and here you will get negative decreasing. And horizontal, very easy. Horizontal means angle with horizontal is 0. Angle is 0. If angle is 0, tan 0. So we know tan 0 is 0. So therefore this is 0. And for the vertical line, angle is 90. That is tan 90. We know tan 90 is infinity. Tan 90 is infinity. So likewise, you can identify all gradient types here, right? And on this single graph, I have mentioned all the gradient types we have, all the gradient types, right? So you have to know these gradient types before moving on to the next part, because based on the gradient and gradient types and all those things, we are doing graph conversions. We are doing conversions, graphing conversions, graph conversions, right? That's a learning outcome here. Okay, take it down. Take it down. Lay down. Okay, right, done. All right. Okay, let's move on. Now let's see what the motion graphs are. Now, from here the note is finished. Not in the sense, this is a general graph in knowledge you have to have before moving on to this part, right? That is what I recall. General graph in knowledge. Okay. Let's see. Okay. Write down types of linear motion graphs. Get in. Types of linear motion graphs. Types of linear motion graphs. First one, write down displacement time graphs. First one, displacement time graphs. Displacement time. Write down displacement time graphs. Displacement time graphs. We call ST. We call ST. Right? We got here. Now this is a sample. Right? Displacement time graph. Displacement and time is always taken to the x-axis. Time is always taken to the x-axis. This is a random graph. Huh? A random graph. Like this, a random graph. Okay. So in a graph, usually we are checking on two things. One is gradient of graph, and the other one is area of graph, area under curve, area of graph. Right? To check gradient, we know gradient is tan theta, or that is delta y or delta x. No, we'll be checking the gradient that way. And if we need to check the area, right? Area is actually the multiplication of axis, because area is the part here, the area which covers under the curve. So we know basically we are finding area as a length into width. No, now here length and width is going to be two axes. So therefore, if you need to find area, area will be the product of vertical axis and the horizontal axis, product of x and y, product of x and y simply, right? Okay, let's see. Now first I am going to check the gradient here. Gradient of ST. Gradient of ST. Gradient of ST is, so we know gradient can be written as delta y over delta x as well. And as delta y here we have delta s. As delta x here we have delta t. Change of displacement over change of time. This is actually rate of change of displacement, that is velocity. Rate of change of displacement, that is velocity. So one idea, one takeout, one learning outcome is gradient of displacement time graph gives velocity, right? And if I check area, there's nothing comes from this area. There's nothing meaningful comes from the area, right? Now if I check this area under curve, see, area is going to be S times T now, right? So nothing meaningful comes. So therefore, no need to check the area of this one. Nothing meaningful comes. Nothing meaningful comes. Okay, take it down. Take it down. Okay. Then number 2. Before that, mention this point in red below this. Mention this point in red with an asterisk mark. Mention this point in red with an asterisk mark here, like this. Mention the point in red with an asterisk mark. Mention uh, gradient of st, gradient of st, gradient of st gradient of st gives velocity. Gradient of st gives velocity. Gradient of st gives velocity. Gradient of st gives velocity, right? Gradient of st gives velocity. Gradient of st gives velocity, right? Number 2, velocity time graphs. Number 2, velocity time graphs. Number 2, velocity time within brackets Vt. This is a random Vt graph, velocity time, right? If we check area, if we check gradient first, gradient of Vt is delta y over delta x. As delta y, we have delta v over delta t. Rate of change of velocity, that is acceleration. And if you check area, right? If you check this area is multiplication of axis v into t, a velocity into time. So we know s equals ut, no? S equals ut, which means velocity into time is a displacement. There is a displacement. So this is displacement. Take it down. Take it down. Okay, below that, mention this point in red. Mention this point in red. In red, gradient of VT, gradient of VT, gradient of VT, gradient of VT gives acceleration. 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 Second point, keep using red. Area of VT gives area of VT gives area of VT gives displacement. Area of VT gives displacement. Right? Okay, number 3, acceleration time graphs. Number 3, last type and the third type, acceleration time graphs. Within brackets 80. This is a random acceleration time graph. Right? So if we check gradient of 80 is delta y over delta x, delta y over delta x, that is delta a over delta t. Right? There is no single term for this. This is called rate of change of acceleration. This is called rate of change of acceleration. And if you check area, area is acceleration into time. Acceleration into time. Right? We know V equals U plus AT. V equals U plus AT. Right? In dimensions, we learn in order to add or subtract two terms, they are dimensionally equal. Then AT is added with U, no? Which means AT is also velocity. AC is also a velocity. It has the dimensions of velocity. Therefore, product AT gives velocity. Product AT, which means area gives velocity. So this area is velocity V. Take it down. Right? Okay. Mention these points in red below the graph. Mention these points in red below the graph. First point, gradient of gradient of gradient of AT, gradient of AT gives rate of change of acceleration. Gradient of AT gives rate of change of acceleration. Right? Gradient of AT gives rate of change of acceleration. Second point, using red, area of AT gives area of AT gives area of AT gives area of AT gives velocity. Area of AT gives velocity. Right. So that is the only theory part we have here in linear motion graphs. Here onwards, we'll see how motion graphs conversions are done, and the last part of this part is solving questions using graphs, which means by using the graph without using linear motion equations. Right. So that's all. That's all as theories. Any questions up to here? Any questions up to here? You can quickly ask if there's anything. Is it all good? All clear? Right. Okay. Then as an next heading, write down. Okay. Okay. As an next heading, write down conversions of linear motion graphs. Conversions of linear motion graphs. Conversions of linear motion graphs. Right. Look at the board. So this is one of the main parts. You are getting questions from linear motion graphs. Graph conversions. Graph conversions can, like, more frequently questions are coming. More frequently, very frequently questions are coming. Like we have one question in one paper, something like that. Like one question in each paper, something like that. One question in each paper. Very frequent. Very frequent. Right. See, let's see how conversions are done. First one, I'll explain this using this graph itself. Take this down with me. This is ST. This is ST. Say ST is given. Say this ST is given. Take this down. Take this down. This is ST graph. This is ST graph. The given ST graph. Now we are going to convert this given ST graph to its respective VD and AD. Its respective VD and AD. This is called a graph conversion. Graph conversion. Okay. Look at here. This is how we do. Now, if I need to convert this ST to VD, so first write down the relationship between these two. What is the relationship? Gradient of ST is velocity, no? Relationship means relationship between displacement and velocity. Right? Displacement and velocity. What we have is proved these are now. Gradient of ST is velocity. Now, if ST graph is given, gradient of ST is known, which means knowing this gradient, look at here, will be same with the velocity. Very straightforward. Therefore, we will check the behavior. We will check the behavior of gradients here. We will check the behavior of gradients here. See, what type of a gradient is this? Straight lines are constant gradients. So this is a negative constant gradient. And this is a zero gradient. And this is a positive constant gradient. You can check from gradient types. You can check from gradient types if you can't recall. Right? Give me 1 second. Okay. You can check from gradient types if you can't recall the types of gradients. Right? Now, once you do 2-3 questions here, you will be familiar with the gradient types, and you have to be familiar. Right? Okay. See, now what is happening with the gradient is same as when we look at a gradient, basically we look at two things. One is the sign of gradient, sign, positive or negative, sign, and then behavior. Behavior means whether it's constant or increasing or decreasing. Right? Only two things. Very simple. Very simple. You just need to look at only two things. Only two things. One is sign. The second one is behavior. Behavior can increasing or decreasing or constant. Okay. Now let's see. Okay. First part. In first part, is a negative constant gradient. If gradient is negative, which means velocity is negative. If gradient is negative, velocity is negative. Now gradient is constant, which means velocity is constant. Right? Which means this is going to be a negative constant value. This is going to be a negative constant value like this. Negative constant value. Right? And this time interval, gradient is 0. Now, according to the relationship, if gradient is 0, velocity is 0. Velocity is 0. So, no velocity here. No velocity here. And here, this is a positive constant gradient. Positive constant. Right? Sign is positive, which means velocity is positive. That is constant, which means that is a constant value. Positive and constant. Finally, you can connect these lines, and what you see here is the respective VD graph. See how easy? This is the respective conversion, ST to ED conversion. Now, if I need to convert it to AD, again, write the relationship between velocity and acceleration in terms of motion graphs and do the same. See, we know gradient of VD is acceleration. Knowing the gradient of VD, you can get acceleration. Right? Now I'm going to check gradient of VD. VD is this one, second graph. Right? This one. These are horizontal line 0, horizontal line 0, horizontal line 0. Which means there is no acceleration for this motion throughout. There is no acceleration for this motion throughout. There is no acceleration for this motion throughout. Correct? So this is called a graph conversion. This is called a graph conversion. Right? Hope it's clear. Take it down. You can ask if anything, if any questions. Okay, then I'll give you another question. Give this a try. Another ST is given. This ST is given. This ST is given. Try to convert this to respective ED and AD. Try to convert this given ST to respective ED and AD. Right? Right. Okay, finished? Finished? Shall we see? Shall we see? See? Now for the first one, VD conversion. First one, VD conversion. So again, same relationship. Same thing, no? Same thing. Gradient of ST is velocity. So check these gradients. These are positively increasing gradient. And this is a positive constant gradient. And this is negatively increasing gradient. Right? So first part, look at your first part. Velocity should be positive and it should be increasing. Velocity is positive and it is increasing. So which means something like this velocity is positive and it is increasing. positive when increasing. And here velocity is positive and but it is constant. But it is constant. Positive and constant. And here velocity is negative. Negative, which means on the other side, negative, and value increases. Increasing means the value increases, negative, and the value increases. So that is negative, and that value increases. This is the respective VD. This is the respective VD. Right? Respective VD. And the reason to say this is starting from 0 is at this point, this is exactly horizontal now. If you check the gradient at this point, see, this point is horizontal. So if I check the gradient at this point, at that particular point, gradient is 0. Right? Gradient of that point is 0. Because line becomes horizontal and comes down. Line becomes horizontal and comes down. When the gradient becomes 0, we know velocity at that point should be 0. That's why it's starting from 0. Then AD. Check this gradient again. This is positive constant, right? And this is 0, and this gradient is negative constant, right? Then acceleration should be positive and constant. Acceleration should be positive and constant. Is it clear? Okay. Next one. Try this. Try this out. Try this out. Finish. Okay, let's see. Okay, let's check. ST to ED, same argument. So we have to check the gradients of ST. We have to check the gradients of ST. These are positively decreasing gradient. These are positive constant gradient. These are negative constant gradient. And this is negative decreasing gradient. Right. So whatever happens to gradient of ST happens to velocity. Whatever happens to gradient of ST happens to velocity. Right. First part, gradient is positive. If gradient is positive, velocity is positive. If gradient is decreasing, velocity is decreasing. Right? Positive and decreasing. And here you can see that is not horizontal. This line is not come into horizontal position. Since there is not come into horizontal position, it means at that last point also there is a non-zero gradient. So it is positive and decreasing, but that is not come into zero. That is not come into zero. And you can verify that from the second part as well. Second part is positive constant, no? So like this, second part is positive and constant. Right? And third part, negative and constant, somewhere here. Negative and constant. And the last part, negative and decreasing. Negative, value is here negative. And finally, can you see this point is becoming horizontal? This line is becoming horizontal, which means at this point, actually the gradient is zero when it is horizontal. So therefore, it is negative and decreasing, no? Negative and value decreases, which means it decreases up to zero. These are respective graph. These are respective graph. Right? Then AD, same thing. Same thing. Gradient of ED is A. So this gradient is negative constant. This is a negative constant gradient. This gradient is zero. This is also zero. This is a positive constant gradient. Right? Right? Then this is negative constant. These two are 0, 0. Both are 0. Both of them are 0. And this is a positive constant. Like this. This is the respective AD. Understood? So those are the graph conversions. Those are the graph conversions. Right? So from here, all theory parts, as theory parts, all the things we need to cover in linear motion is covered already. By next day, you will get the route, and from the route, we will be discussing more questions. And then next day itself, we can start projectile motion. Next day itself, we can start the next lesson, projectile motion. Right? Any questions from the things we covered today, from the parts we covered today? Any questions from the parts we covered today? On Zoom, YouTube? Most of you are still there, right? Any questions? All right. So if there's no questions, we are going to wind up the first day, first class, right? So go through everything we covered today. Now, basically, I have covered all the theory parts, which is relevant to the linear motion. right? Basically linear motion equations, applications, and linear motion graphs, right? And we will be practicing more questions next day, and we are going to start projectile motion, right? Okay, and as I told you, if you are joining the bounce back program, you have to also join the 5-day class this week onwards, right? This week onwards you can join. You have to join, actually. You have to join the 5-day class, because now this Friday we are going to start a new lesson. So you can start learning that new lesson from the latter part of mechanics there, right? So what we are starting that day is actually center of gravity, right? So please join there 3:30 on Fridays. That is the regular 27 class batch, 27 theory batch. So you can join there and cover the things from center of gravity there from that class, right? Okay then. So I'll share a message in the bounce back group as well, that you have to join Friday as a reminder, right? As a reminder. Okay then. So that's it. That's it. So we'll wind up, go through everything, and come to the next class. We'll meet again on next Wednesday, same time at 7 p.m. Right? Then yeah, if there's no questions, we'll wind up. Stay safe and study hard, work hard, especially if you are a 26 batch student. Now you have got only like a few time means now if we are having the exam in August, right, which means it will be during the second week, most probably during the second week of August, right? So which means from 26 we have got only 7 months, 7 complete months. Now from here we have only 1 month remaining, so almost in 8 months now, just in 8 months of period you are going to have the exam. That's a not that kind of a significant, a considerable period. 7 months, 8 months means that is flying, the time flies. Okay, so work hard, study hard. See you all in the next class. Good night and goodbye.